Hello, today I'll be talking about Euler's method. Euler's method is a simple numerical method used to solve ordinary differential equation. It is similar to the tangent approximation method but with course correction. It is a less accurate method as it is approximating its next point. Over here, we can see the formula for Euler's method. Yn plus 1 equals yn plus hf xn yn. Yn is basically the starting point and yn plus 1 is the next point which you are trying to find. So how do we get this hf, xn, yn? We look on the right hand side of the graph here. So basically this graph is showing we draw a tangent line at this point xn, yn, which will give us this tangent line here. And h is basically the difference between the two values, and you can change this h. With a lower h, it will be more accurate, but in this case, h will be equals to 1. But we'll leave it as h. So in order to find this rise here, we'll have to use the gradient formula, which is here, m equals rise over run. So rise is equals to n times run, which will give you the hf xn yn, which is shown here. So this value is basically the difference between yn plus 1 and yn. So if you add it back, yn plus this, it will give you yn plus 1, which is the formula.
For this next part, we'll be using an Excel spreadsheet to help us do the calculations, as the calculation can get quite tedious over time. Over here, you can see the formula for the Euler's method and the equation we're working with. So what this means over here is our initial condition. When x equals to 0, y will equals to 1, as we have set over here. When x equals 0, y will be 1. The next thing we must do is to set our step size. So I'll set it to 0.1. This will give us all these values here. X is basically the increment of our step size. But this y is basically our formula here. Yn, which is B3, the previous one from B4, and plus h is basically set as this step size here, which is set as A3, since A3 equals A2, times C3. C3 is basically just this equation over here, which is given in the question, x over y squared. So you get this equation over here. After you get this value, you put it in. And what we are trying to find here is when x equals to 1, what will the value of y be? As we can see here, find the approximate value of y. So when x equals 1, y is 1.3393. So if we decrease our step size, we will actually get a more accurate value, as we can see over here. So if we scroll down to find the value of x equals to 1, we will get a value of 1.355 for our y value now. For this last part, we'll be solving these IDPs via general solution. Firstly, we'll cross multiply both of these and we'll integrate both sides, and we will get this equation over here. And our initial condition is when x equals 0, y will equals to 1. And this will allow us to solve for our constant, and we found constant to be 1/3. We will sub in constant with our equation here, and what we want to actually find is when x equals to 1, what is the value of y? Therefore, we will sub x equals to 1 and solve for y. After we have solved for y equals to plus minus 1.5811. Looking at the Excel, which uses the Euler's method, we can see when x equals to 1, y equals to 1.339. This is the approximation error between the general solution and Euler's method. However, this can be fixed by changing the step size to a lower value, which will give us a closer answer to the general solution.